Dr. Babasaheb Ambedkar Open University.
Namaskar dear students and learner of this course. I am Professor Kamesh Rawal. I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. I think in the last session we have discussed about the programming languages, right? So we have discussed there are mainly 4 type of programming languages are there. One which machine can understand, it is known as a machine level language. Then we have the assembly language in which we can use a mnemonic codes, right? But to translate it we need a assembler, right? So after writing the code, your English statements get translated by the assembly your assembly code get translated into the machine level language or binary language by the assembler. Then we have seen a compiler and interpreters are there, level languages. Finally, we have discussed what is actually 4th generation language, and that is basically used to operate the various databases, right? So SQL or structured query language, it is the 4th generation language. Then we have discussed 3 main type of processings, right? In one processing, what we are doing is most of the time, CPU is very fast, while the other IO devices like printer or we can say keyboard, monitor, these IO devices are much more slow compared to the speed of the CPU. So what we are doing is, how can we utilize the speed of the that CPU? So for that, what we are doing is all the IO instructions, data and everything, processing instructions and data, we are collecting in the form of batch, and then entire batch we are giving to the CPU, and within a fraction of second the CPU will process the thing, right? So by this means we can save a lot of time of the CPU, right? Once the job is done, you can submit the another job. So to utilize the speed of the CPU, what we have done is, we have collected all the IO statements, all the data and everything into the form of batch, and then you submit entire batch to the CPU so that the CPU speed can be utilized. The another way to utilize the CPU speed is, so here basically what we are doing is, we are having suppose one CPU, suppose 3 or 4 users are using the speed of the CPU, right? Here what CPU will do? CPU will give or take the job from one particular person. It will do the process for some time. Then after some period of time, the CPU will be allotted to the second user. Then again the CPU will do the work of second user for few fraction of seconds. Then the CPU will turn back to the third user and so on. So here multiple users are working with the CPU, right? One CPU. So here the CPU is sharing its time between a many user, right? Many users are working at the same time with the one CPU, and that is what that type of processing, online processing, is known as one is a batch processing, second is a online processing. The third processing, right, in which because the application is a time critical, it has to complete it in some designated period of time. Here we are just submitting only one job to the CPU, and 100% of the CPU will be utilized by that particular application. Why? Because the application itself has to complete some work in some designated time period, right? So here no other application, no other user is allowed, right? So that is called a real time processing, right? So time sharing, real time, and we can say offline batch processing. These are the 3 different type of processings are there. Okay. Now in this particular unit, we will learn a number system, right? As in the last session we have discussed, the machine can understand what? Machine can understand only a language of ones and zero. So basically that is called a binary, right? So how can we compute a binary? Suppose some number is given to you, right? Then how can you compute a binary, right? Similarly, binary is not only the numbering system. There are 4 numbering systems are there, right? So first of all, we will just try to understand what these 4 different type of numbering systems are there, and then we will see how can we convert a number or data from one numbering system to another numbering system. Okay. So basically in this particular session, we will just focus on what actually the number system is there, and then we will discuss 2 different number system, decimal number system and binary number system, and we will see how can we convert a decimal number into binary and binary number into a decimal, right? Okay, fine. So as I said, there are 4 different type of number systems are there, right? Which number system which we are using in our day to day life? Obviously it is nothing but it is a decimal number system, right? So first we will just start with the decimal number system. The base of the decimal number system is 10. Why? Because when we are writing the number in which each digit can be from this set, right? Now you just see in the set how many symbols are there? 0, right? Then 1, then 2, 3, 4, 5, 6, 7, 8 and 9. Total there are 10 symbols are there, and that is why what we can say is our decimal numbering system which we are using in our day to day life, that has a base 10, right? Because each digit can be from this 10 possible symbols, right? So it is called a decimal number system. Okay, so this is what we humans are using a decimal number system in our day to day life. But in the previous session we have discussed machine cannot understand all these things. Machine can understand what? Only one language, and that is the language will have 2 symbols. So that language which is having 2 symbol is called a binary, right? So binary, the base of the binary numbering system is what? 2. Why 2? Because in the binary numbering system there are only 2 symbols are allowed. One is a 0 and another one is 1, right? So binary, it is a numbering system whose base is 2 because it uses only 2 symbols, 1 and 0, right? Second, that is called a decimal number system which we humans are using in our day to day life, right? And that uses 10 symbols, 0, 1, 2, 3 up to 9. Total 10 symbols are there, that is why the base of this decimal number system is 10. Similarly, apart from this 2 numbering system, binary and decimal, there are 2 more systems are there. One is a octal number system. In the octal number system, there are only 8 symbols are allowed, and those symbols are 0, 1, 2, 3, 4, 5, 6 and 7. Total 8 symbols are there, and that is why the base of this octal number system is 8, right? One more number system is there which is known as a hexadecimal number system. Now in the hexadecimal number system, what we have is we can use a 16 symbol to represent a single digit of a number, right? So total 16 symbols are there, and that is why we can say the base of this hexadecimals is 16, right? Now you people might think, okay sir, 0 to 9 fir kya? There are 10 symbols are there. No, 10 you can represent with A, 11 will be represented as B, 12 will be represented as C, 13 will be represented as D, 14 will be represented as E, and 15 will be represented as a F, right? So total up to 15, right? From 0 to 15 you can use just a single digit, and that is why hexadecimal will have total 16 symbol and its base is 16. Okay, we will see one by one numbering system in detail. So as we have discussed, in the decimal number system what we have is we can use a 10 symbols. So total 10 symbols are there, right? And this 10 symbols are what? 0 to 9, right? Suppose if you are writing this type of number, which we in our daily life we are using this type of number like 5432, right? So what is the meaning of this number? So that means 5 should be multiplied with 10 raised to 3, 4 should be multiplied with second digit, 4 has to be multiplied with 10 raised to 2, 3 will be multiplied with 10 raised to 1, and 2, the last digit of the number has to be multiplied with 10 raised to 0. Now, we know that whenever we are doing a power of any number, and if the power is 0, that will represent what? 1. So, here 10 raised to 0 is 1, sorry, 10 raised to 0 is 1, yes, 10 raised to 1 is 10, 10 raised to 2 is 100, and 10 raised to 3 is 1000, right. So, 5 into 1000 plus 4 into 100 plus 3 into 10 plus 2 into 1, right. So, that will make 5000 plus 400 plus 30 plus 2, and it will gives you your number, right. So, whenever we are writing something like this 5432, it means this thing, right. Okay. Let if we talk about a binary. So, in the case of binary, you know, we do not have 10 symbols, we have only 2 symbols, right, and that symbols are 0 and 1, right. So, the base of the binary numbering system is 2, and we are using only 2 symbol, one is a 0 and 1. Okay. So, here you just see we have returned a decimal number, right. So, we have started with 0, then 1, then 2, right, then 3, then 4, then 5, 6, 7, 8, 9. Now, see, when we are here at 9, you know, at that time all the symbol gets completed, right, because how many symbols we have? We have 10 symbols and we are starting from 0. So, 0 to 9, when we are writing 9, that means all 10 symbols are completed. So, now we need to switch over from a single digit to 2 digit, and what is the first 2 digit number? It is 10, right. So, here 2 digit has been started, right, then 11, then 12, 13, 14, 15, you can go up till 99, right. When you reaches at that point like 99, then all 2 digit symbols, 2 digit numbers are completed, right. Then you need to switch over to a 3 digit number, right, like 100 is the smallest 3 digit number, fine. Now, the same thing I have written in the binary. So, here 0 will be represented as 0, 1 will be represented as a 1, right. Now, you know, in the binary numbering system just 2 symbols are there, 0 and 1, and both we have used. So, what is the next number? So, obviously, you need to use a 2 digit number for, you know, representing 3, right. So, to represent 3, we need to use 1 0, okay. Similar to this, after 9, what we have is, we have 1 0. Similarly, here we have used a 0 and 1. So, now all the single, all the symbols we have used for single digit, and once all the symbol we have used for single digit, we need to switch over to 2 digit number. So, this is what the first 2 digit binary number, okay. So, 2 will be represented as a 1 0, 3 will be represented as a 1 1. Now, you know, all the 2 digit symbols are over, right, like 99. So, after 99 we need to move to the 3 digit number like 100. So, similarly, if we have used all the 2 digit symbols, then we will switch over to 3 digit like 100, 101, right. Make sure you can use only zeros and 1, right. 6 will be represented as a 110, 7 will be represented as a 111. Now, you know, this is the same situation like 999. So, all the symbols are used, right. So, after 999, what we are writing is, we are using 4 digit number like 1000. So, here the same thing is there, right, 1000, then 1001 and so on, right, 1001, 1010, 1011, it will represent 11, 1100, it will represent 12 and so on, right. Okay. Now, suppose if we want to compute a binary, suppose 19 is decimal number which is given to you. Now, see, if you are look at to this number, now you should know this is a decimal number. Why? 9 is there, and because the 9 is there, we can say this is the decimal number, right, because in the binary 9 is not there. Suppose somebody has given a number to you like let 19, right, and you have to convert it into the binary. Then what you need to do is, you need to divide that number by 2, right. So, I will just start dividing this 19 by 2. So, here I will write 2, okay. Now, you know that 2 9s are 18, right, but the number is what? 19. So, 1 is a remainder you just write it down here, Okay. Again what we will do is we will try to divide this 2, right, by 9. So, we know that 2 4s are 8, okay, 2 4s are 8, but which number we have? We have 9, okay. So, again there is one remainder is there. Again what we will do is we will try to divide this 4 by 2. So, 2 2s are 4. So, here obviously we will get 2, okay, and here the remainder is 0 because 2 2s are 4 and what we want is 4, right. Similarly, again we will try to divide this 2 by 1, sorry, 2 1s are 2, what we want? We want 2. So, 2 1s are 2, so there is no remainder is there, that is why we will put 0 here, okay. Now, 2 zeros are 0, okay, 2 zeros are 0, but you need to bring what? 1. So, obviously this 1 will be a remainder, okay. And let if you write this all remainders in this way, okay, in this way, suppose if you are writing means 1 0 0 1 1, okay, and this is what it is called the binary of 19, okay. The thing is, whenever any decimal number is given to you and if you want to convert it into the binary, make sure you just need to divide that number by 2 every time unless and until you are not getting 0, right. Now, one question will arise into your mind, sir, why we are dividing the number by 2? Because you are converting decimal number into the binary and you just think what is the base of binary? It is 2. So, whenever any decimal number is given to you and if you want to convert it into the binary, what you need to do is you just need to divide that number by 2, right, and you just have to here you just have to collect all the remainders and afterwards you just need to write all the remainders into the reverse order like this, first 1, then 0, again 0, then 1 and 1. This is what it is, a binary of 19, right. Similarly, you just try to convert this 54 into the binary and this 153 into the binary, okay. See, the answer is this. See, what we have is we have a 54. So, first of all what we are doing is we are dividing 54 by 2 because it is a even, you are getting remainder 0, right, and we know that 27 2s are 54. Again you need to divide this 27 by 2. So, you know 13 2s are 26, right, but number is 27. So, we are putting one remainder here. Now, what we have is we have a 13. So, 13 again you try to divide 13 by 2. So, we know that 6 2s are 13, right, sorry 6 2s are 12, but here which number we have? We have 13. So, here one remainder is there, right. Now, which is the next number? 6. So, we need to divide 6 by 2. So, we know that 2 3s are 6 and because you know the number is a 6 and 2 3s is 6. So, there is no remainder is there. So, 0. Again what is the next number? 3. So, here 2 1s are 2, but what we want is we want 3, right, 2 1s are 2. So, here one remainder is there, right. Similarly, 2 zeros are 0, the number becomes 0 and whatever is here let 1, that will be your remainder. And finally, you need to write down into this way 1 1 0 1 1 0. So, this is what it is, a binary of 54, right. Okay. Let any number is given to you, for example 173 is given and if you want to convert it into the binary, if the number is bigger obviously the string of binary will be increased, right, the length of the binary string will be increased, fine. If 173 is there, so first of all what we will do is first we will just consider, see 1 is not divisible by 2. So, I am just considering this 17. So, 2 8s are 17, right, 2 8s are 16. What we want is 17. So, here 1 is there. So, 1 and 3 will make 13. So, 2 6s are 12. So, again this is last is 13 and here what we have is 12. So, 1 is a remainder, right. It is something like this, see, let 1 7 3 173. Okay, if we are dividing it by 2, right. So, first of all I will just try to divide this 1 by 2, right, but 1 is a smaller number than 2. So, I will consider 2 digits, I will consider 17, right. So, 2 8 ja 16, but this number is a 17. Okay. So, here 1 is a remainder you put it here. So, now this number becomes what, 13. Okay. So, 2 6 ja 12, but the number is 13. So, remainder is 1, and that is why I have written 86 here, it is a divisal, and this 1 is a remainder. Okay. Similarly, you just divide this 86 by 2. So, the half of 8 is 4, half of 6 is 3, so 43, right, because 86 is a even number. So, there is no remainder is there. Similarly, 2, we need to divide this 43 by 2. So, we are getting 21, but 21 2s are 42, right, but number is what, 43. So, here one remainder is there. Similarly, try to divide 21 by 2. So, 10 2s are 20, which number we want to bring, 21. So, 1 is a remainder. 2 5s are 10, because 10 is a even. So, there is no remainder. 2 2s are 4, but the number is 5. So, 1 remainder, right. 2 1s are 2, so there is no remainder. 2 zeros are 0, so 1 is a remainder. You write it down all this thing into this, in this way, 1 0 1 0 1 1 0 1, right. So, that will becomes a binary of 173. Okay. Now, suppose if someone says this is the binary which is given to you, you convert it into the decimal, right. So, here what we need to do is, this is the binary which is suppose given, right. So, here I have used 2, means this is a binary number, and make sure here everything is written in the form of 1s and 0, right, means it is a binary number. What we need to do is, we just need to convert it into decimal. So, how you will do? You just count how many digits are there. So, this is digit 1, 2, 3, 4, 5 and 6. Total digits are 6. If 6 digits are there, you just need to start from 2 raised to 5. Okay. If 6 digits are there, suppose if n digit is there, you have to start with n minus 1. So, here if 6 digits are there, I will start with 2 raised to 5, I will put 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1, okay, and 2 raised to 0. Then here you need to write your binary. What is the binary? 1 0 0 1 1 0. Okay. Now, see what is 2 raised to 0. So, as I said, any number whose power is 0, it will be treated as a 1. Okay. So, similarly, suppose if you are counting this 2 raised to 5, so it is 2 into 2 into 2 5 times. So, it is 1 into 32 plus 0 into 16 plus 0 into 8 plus 1 into 4 plus 1 into 2 plus 0 into 1, right. So, that will what? 32 plus 0 plus 0 plus 4 plus 2 plus 0, and it will make what? 38. So, 38 is what? It is a decimal number. So, here we have represented it as a 10. Okay. Similarly, suppose if this is the number which is given to you, then you just write down that binary 1 0, okay, 0 1 and 1. Similarly, what is the next step? You just need to count how many digits are there. So, there are total 5 digits are there. So, obviously, we will start with 4, 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1 and 2 raised to 0, right. 2 raised to 4 is what? Is a 16. So, 1 into 16, 2 raised to 3 is 8. So, 0 into 8, 2 raised to 2 is 4. So, 0 into 4, 1 into 2 because 2 raised to 1 is 2, 1 into 1 because 2 raised to 0 is 1, right. Similarly, let 16 1 ja 16, 0 into something is 0, okay, 0 into 4 is 0, 1 into 2 is 2 and 1 into 1 is 1. Finally, if you are adding this 16 plus 2 plus 1, you will get 19. So, you can understand this is what it is, a binary of 19, okay, fine. Similarly, here you know you have the binary, you just write down that binary, that is 1 0 1 0 1 1 0 and 1. You just count how many digits are there. So, obviously there are 8 digits are there. So, you just need to start from 2 raised to 7, 2 raised to 6, 2 raised to 5, 2 raised to 4, 3, 2, 1 and 0, right. 2 raised to 7 is what? It is 128. So, 1 into 128, 2 raised to 6 is 64. So, 0 into 64, right. If you are doing 2 into 2 into 2 6 times, you will get 64. Similarly, 2 raised to 5 is 32. So, 1 into 32. Similarly, 2 raised to 4 is 16. So, 0 into 16. 1 into 8 because 2 raised to 3 is 8. 1 into 4 because 2 raised to 2 is 4. 0 into 2 because 2 raised to 1 is 2. And here you are getting 1 into 1 because 2 raised to 0, any number to the power 0 is 1, right. And then you do the multiplication and whatever numbers are there, you do the summation of it. So, you will get 173. Similarly, try to do this thing your own, right. Suppose if the binary number is given to you which is 110110, right, then how can we convert this number into the decimal, right. Your answer should be a 54, okay, fine. So, here in the today's session, what we have done is we have tried to focus on the variety, the different type of numbering system, right. So, mainly 4 number systems are there. One is binary number system is there, octal number system is there, decimal number system is there and hexadecimal number system is there. What are the base, what type of symbols we are using in each decimal system, that we have discussed, fine. And we have learned how can we convert a decimal number to binary as well as binary number to decimal, fine. In today's session, we are just keeping our discussion up to here. In the next session, we will see few more numbering system and their conversions, right.